Hello, hello, welcome back. And today I've got more plutonic processes for you. And here we have a specimen of the well-known and rather famous Harrisite. This is a boulder I picked up in Harris Bay on the Isle of Rum. This is the type locality for Harrisite, and this was nicely polished by the wind and the waves, so it was easy to pick up. So I didn't remove this from an outcrop, but it nevertheless gives us some very good ideas. And what we see here is a lot of olivine, and it's almost like, well, I guess little leaves or grasses. I think spinifex texture would be a term to use. Spinifex is a plant in Australia which has these long, thin leaves, and this is a bit how it looks here. The other side of the specimen here is a rather fine-grained basaltic rock. Let me show it to you. So I think this is a later dike, and this is not so important, but this material here is quite fascinating. So here we have these large olivine crystals, that's the dark materials, and here we see them, and then there is some feldspar in between the olivines, and the feldspar is likely enclosing much of the olivines. And let me turn this around here. So, and the interpretation is that these olivines grew rather rapidly from a substrate, probably upwards, but it's very hard to tell, particularly in this boulder, and also they're a bit kind of random. So to me, this is more like they grew quite randomly into all sorts of directions, probably from a substrate upwards. But it is widely considered as a form of in situ crystallization, where we have these kind of crystals growing almost in a crystal garden from the floor upwards. There has been calculations made on these rocks in terms of how long it would take for these crystals to grow. And let me just turn this around here a little bit. And well, there's different estimates, but the fastest I heard is that some of these kind of up to 10 centimeter crystals may have grown in hours to days. And they must have grown in rather idealized conditions. And this is what I think we're seeing here. Now, if this happens, then obviously we must be depleting the liquid in some of the components that the olivine certainly needs to grow, and most likely that would imply that, here's one of these nice olivines, this would imply that the liquid in the magma body overlying this boundary layer where this crystallization happened would have changed its composition. And here it is actually the liquid that was likely moving rather than the crystals. So this is a form, a special form of cumulate. It's in situ grown crystals, and the liquid would have moved in between them and would have been expelled from an increasingly denser crystal arrangement into the liquid body above, and therefore it might have caused fractionation there. So I'd like to kind of think that this gives us a little bit of an idea about how these type of rocks work. And let me see whether I get a last shot here. That is good enough. Yes, I think so. And let me say thank you again, and I'll close with an invitation for the next video that's to come very soon, I hope. All the very best. Bye-bye.